Okay, like I said, we're going to talk about CSS, and CSS means cascading style sheets. And this is going to be a presentation language, right? So we're going to use it. We already have structure from HTML. So we're going to use CSS in order to specify how the structure should be drawn. Now, what is this going to entail? So I need some components. First of all, I need some properties which are going to have presentation significance. Right. So I want to be able to say if a certain node in the tree, which represents a tag, is going to be blue. Okay, the next thing I'm going to need is some way of associating these properties to the nodes in my tree. How can I do this? Well, I can do it in a workman-like fashion, right, which would involve rudimentary tools, or I could use some sort of language which is going to allow me to select a subset of the nodes of a tree. And I have such a language, a complex language, which is CSS selectors. This is going to be our first big topic, which is CSS selectors. Now, I needn't necessarily use CSS selectors just to apply styles. Right? It's a language which allows me to just select a subset of the nodes of a tree. I'd use CSS selectors, for example, if I'd want to automatically add event handlers to a certain kind of component. So to specify what happens when you click it. But it has more use than CSS itself. This is a primarily styling mechanism. It includes positioning mechanisms. Now, it separates presentation from structure, obviously. And the presentation rules are usable and can be composed, which means that, for example, if I define some sort of behavior in some sort of presentation in a style class, I can use multiple classes on a particular component. So I think I already gave this example, but if I have a registration form, the registration form is going to be something which is larger, and its buttons are going to be specific. I want the actual register button to be a call to action button, to pop out and invite the user to, to actually register. Now, assuming after I've gone through the tree and I've associated styling properties to all nodes, assuming I already got to this step, I then need the mechanism for which to actually draw the tree, right? And this is going to be the second grand topic in which we discuss how the drawing flow functions and how components are actually drawn. Okay, so I can include CSS in my HTML files via a series of mechanisms. So first of all, I can use external styles, which are external resources, including a link, which is going to be a tag which appears in the head part of my document. And I'm going to specify a CSS file, and the browser reading the link tag is going to infer that it needs it to display the actual page, so it's going to request it separately. Now in HTTP 2, I have something which is called the link header, which is going to allow the server to actually push the resource to me. Right? The server already knows I need the CSS to display the page, so it's going to push it to me. Then I have a style block. And the style block is going to allow me to put CSS rules in the HTML file itself. Now, the more I do this, the more I omit keeping presentation separate from structure, the more unmaintainable my source code becomes. And the third thing is I have a global attribute which is called style, which allows me to put inline properties. And the special thing associated with this attribute is going to have precedence over anything else, with an important exception, but we're going to see that. But the idea is that no matter what rules would apply, if I put something in the style property which conflicts with them, the style property would take precedence. We're going to see shortly how the precedence rules function in CSS. But this is always going to hold unless I use a special word which marks a rule as important, which is important. I mark a rule as important, and then it's going to apply even over the style attribute. So inline styles have precedence. Now, when talking about precedence of rules in CSS, I'm going to have a naive approach, which will sometimes lead me to trouble, but is good enough for most cases, and the actual approach. The actual approach actually assumes that I'm calculating some numbers. Right? The actual precedence of the style rules is going to be based on something which is called specificity. And we're going to go over that, but the general rule is that, at least for non-complicated, for trivial cases, more specific rules are going to take precedence over more generic rules. And this, to a certain extent, reflects in the calculated specificity. But there are some cases in which the calculated specificity isn't going to go the same way as my intuition. Right? It's going to contradict what I get from somebody who doesn't know CSS. So if I just describe some sets of things to a person, I'm going to get a different response than I would have gotten by calculating. Now, for identical rules, identical in the sense that they have the same specificity, I'm going to have precedence of the last one defined. Right? So if I say that all divs are blue, and then I said all divs are red, the red rule is going to be the one taking precedence. Now, if I mark something as important, everything else goes out the window. The rule marked as important applies. Right? It applies over stuff which is more specific. It applies over stuff which is written in the style attribute. It applies over everything except for another rule marked as important. So what happens is the precedence mechanism is suspended when I mark something as important. And if I have a conflict between important mark rules, the last one applies. It's just consecutivity. It's just the last one. Now this also should be used sparingly, because what's going to happen with the important rule is that whatever reasoning I had in my head about the way the style of a particular application is defined, it's not going to apply if there's an important rule, right? So I'm thinking about how things are represented, but there's an important rule which is going to make things impossible to reason about in specificity terms, right? So important is a last resort. Now the general form is you have to have a selector, and then I have a block of rules. And the block of rules, they are between curly braces. The rules themselves are key value pairs, and they're ended in semicolon. Now keys are either attributes, so they're either properties which appear somewhere in the structure of the object corresponding to the tag, or they're pseudo attributes, right, which allow me to manipulate multiple values at the same time. And in order to understand why pseudo attributes are useful, let's take a simple example. If I have the border of a box, right, the border itself has characteristics in all directions. So it has characteristics to top, bottom, left, and right. Now I might want, in some cases, to define these specifically. To say, to the left I have a border which is like this, and to the right, the border which is thinner. But generally, I'm not going to need this. So I'm going to have just one attribute which encompasses all the directions, right? So top, bottom, left, right. The second thing is that the border might also have characteristics which are different from just which allow me to define how the border is going to be drawn. So, for example, a border might have a border style. Instead of being a solid line, it might be a dash line, right? Something with little spaces, or it might be a dotted line. And I'm going to have just one attribute, which will allow me to say the border color, the border thickness, and the border style just in one line. And this is going to apply in all directions unless I decide to be more granular. Okay, so that's with the keys. The selectors themselves are search expressions through a tree. Now, the tree is incidentally my DOM tree, but if I'd have some other kind of tree and I define a search language, it would most likely look very similar to CSS, to the one in CSS. Now, another note is that I have something which are called pseudo classes and pseudo elements. These are added either for ease of use. So, for example, I'm going to be able to select the first letter in a particular text block. And now I could do this manually. I could put that first letter for each of my text blocks in a separate tag. But that would really lead to to an HTML source, which would be hard to manipulate, right? Because it would have this useless little thing. So I have this mechanism for which I can just say the first letter without actually defining it. It's going to be treated as if I had defined it. Now there are other things which are difficult to select or impossible to select. For example, this, right? The idea of a text selection, the way a text selection looks. Would I have an interest in actually being able to style this? Yes. If I make an application which is black and white, I'd be bothered by the fact that this is blue on, it's black on blue. It would lead to something which doesn't look cohesive to the theme of my application. Now, if I think of the DOM though, where would I get this from? Is this something in the DOM structure? And the answer is no, and I can't actually access this anywhere. So I have these things which allow me to select stuff which I wouldn't usually be able to select. Okay, so let's look at the selectors themselves. And with this occasion, let's talk about specificity. So specificity is a tuple of numbers. Now the numbers have positions, and positions are more relevant when they're further to the left, just like a regular number. In fact, I can treat specificity as if it was a regular number, only my number is not in base 10, but it's in a very large base. So I'm going to have something like 1, 13, 26, right? 10. Now, in the usual case, I'm never going to run into something like this, because if I have a selector which has 50 components, that is no longer maintainable by a human being. So selectors are going to look a lot more tame than that. But if, for example, I had a selector which is 1964, if instead of 9 I'd have a 10, I wouldn't have a transport. It wouldn't function like a number in decimal. Understand the concept? So it's like a number in a very large base. Now, I have 4 positions. What are the 4 positions? So the first position is going to be the presence or absence of a style attribute. Right? So if something is defined on the style attribute, the property, then that takes precedence. That has larger precedence than anything else. The second position is going to be ID selectors. And how am I going to get the number? Well, I'm going to look at my selector. I'm just going to count the IDs. Right? So if in my selector I'm going to run into 3 IDs, I'm going to have on the second position the number 3. The third position from the left to the right is going to be for class selectors, attribute selectors, and pseudo class selectors, where pseudo classes function in a way very similar to pseudo elements that I mentioned before, in the sense that, for example, I might want to select the first child of a particular tag. And now I could go to each first child and put a class of first. But that again would lead to some really stupid consequences, right? I'd have some source code which would look very bizarre. Because think about it like this, maybe I do this for first, but how would I mark the 7th child? Right? I'd have to just number everything. It wouldn't be, it would no longer be maintainable for a classical text editor like we're doing. It's become really, really complicated. And more importantly, because we're not necessarily attached to writing everything in a text editor, more importantly, it would become larger, right? And this is the primary restriction when we're talking about stuff which resides on the internet. It should be as small as possible, because you're transferring it over the network. And the more it takes to transfer it, the larger the commercial cost. Amazon actually did a study on this, and they actually tried to calculate how much each tenth of a second costs them. Right? And it's, you get some impressive numbers. It actually costs you a lot. The fact that it doesn't load, it costs you a number of users or a number of products and so forth. So you want it to be as small as possible in order to have as fast as possible transfer. So it wouldn't make sense. So I'm going to have pseudo classes, which are going to work as if I had associated those classes, but without me needing to do that. And the last position, which is going to be the fourth, is going to be reserved for elements and pseudo elements. Okay, so let's go through these. And the first one is an ID selector. It's sharp something. In this case, in this example, it's something with the ID my table. I then have an all selector. The all selector has a specificity of 0. It affects all elements, so it can't be more specific than anything else. Then I have the class selector. This is going to mean something with the class specified, so it's dot something. In this case, it's something with the class some class. Then I have the element type selector, and for example, if I just say div, that's going to mean all div. If I say A, it's going to mean all anchors. IMG, all images, and so forth. Then I have an and selector, and this is just going to be a comma. These are actually separate selectors. So if I have a bunch of style rules which apply to different sets of things, I can just group them and put all the selectors separated by a comma. So in this case, if I have P, div, and form, this is going to be mean that those properties are going to apply to all P's, all divs, and all forms. This is going to be equivalent to taking that block and writing them separately, right? I'm saying just all P's, these rules, all divs, these rules again. But I have this form in order to not repeat myself, to write a lower number of characters. Then I have something which is a descendant selector. Now, what would a tree descent operator mean? Because space is actually an operator, which is going to mean that I can't write spaces wherever I want in a selector. For example, in this if I have D space P, this is going to mean all P's which are descendants of these divs, which means that the P's are somewhere in the subtree of a div. These are already composite selectors, so they're not necessarily children. They might be grandchildren or grandchildren and so forth. They're somewhere in the subtree of a div. Now this is going to mean that I'm going to have a series of gotchas. So let's see. This is going to mean that, for example, if I say something like this, this is going to mean divs with class alpha. But if I say something like this is going to have a separate significance. This is actually going to mean elements with class alpha, which are descendants of divs. So whenever I meet a space, I have to go down at least a level in the tree. Is it clear? Well, if I have a descendant operator, I also should have a child operator, because this doesn't allow me to differentiate between stuff which is in the children collection of a particular tag and stuff which is just in the subtree. And this is going to be the direct descendant selector, which is going to be a greater than. And in this case, it's going to mean P's, which are children of divs, where children are direct descendants. Now, what we've seen until now are the generic selectors, so the ID, the class, the type. Then we saw some selectors which work with hierarchies, right? So both the tree descent operator and the direct child operator work with hierarchies. They assume different levels of a tree. Now we also have a series of selectors which work among siblings, right? So I have a plus and a tilde. And the tilde is they're actually inverted, because the plus is all the elements which are directly preceded by. Okay, so this is going to mean all the P's which are directly preceded by divs. So they have to, if you think of the children collection, they would have an index which is the index of the div plus 1. While the tilde is going to just mean that they have an index which is larger than the index of the div. And so the tilde is going to take everything that's preceded by a div, all the p's that are preceded by a div, while the plus is going to take all the things which are directly preceded by a div. Okay. Then I have to think about the fact that there are still some elements amongst which I can't differentiate. If I think about input tags, right? What makes input tags different? How do I know that something is a checkbox, which has to be styled a certain way, or a button? Well, it's the value of the type attribute. And there's nothing else different, unless I use IDs or classes. And if I'd use classes, I'd end up with something really strange, right? I'd have something which says input type text, class text. I double the information. So I have some selectors which work with attributes. And the first one is this one. So it's with between square brackets, I'm going to have the attribute. In this case, I have a href, square bracket open, href, square bracket closed. And that means all the elements which have the specified attribute defined. Now, if we think about checkboxes, for example, checkboxes can have an attribute which is called checked. So this would allow me, this kind of syntax would allow me to select all the things, all the checkboxes which are checked, which might be styled differently from the checkboxes which are unchecked. Now, apart from this, I have a series of operations which I can use to look inside the value of the attribute. The first one is equal. This is going to mean all the elements for which the specified attribute is equal to the value. In this case, all the elements for which type has the value text. Apart from this, we'll get back to this one. Apart from this, I'm going to have some operators which are going to look very similar to the things I have for regular expressions in Unix, if you remember. So this is going to be start with. For example, I might want to select all secure links. So that means all links for which the value of the href attribute starts with HTTPS. $= is going to be ends with. So for example, I might want to select all the images for which the image is a JPEG. Then I have contains $. This is going to be all the let's say I want to take all the links which are from a particular domain. Right, so that's going to entail saying all the links for which the href attribute contains Google. And apart from this, I'm going to have this one, which is word contains. Now, word contains is a bit different from contains in the sense that it says it asks if the attribute contains something as a separate word. What that's going to mean is that the attribute is going to contain the specified value either as the only thing, right, or at the beginning succeeded by a space, or at the end preceded by a space, or somewhere in the middle, both succeeded and preceded by a space. To give you an example, because that might be unclear, if I take this and this, both of them contain A, but only the second one, a word, contains A, okay, as a separate word. And the reason why I might need this is that I have a series of attributes, like the attribute class, which can contain, instead of one value, a series of values. So I'm going to get something like this. I'm going to get class is button large positive CTA. Right? So I can see why in the case of such an attribute, I'd have an interest in saying if something is word contained, not just contained. Right? Because I want to differentiate between button like this and, for example, another class, which isn't a separate word. Now that being said, I noticed something else. That if, for example, I'd write something like this, this would be basically equivalent to something like this. Right, so it's with the class alpha, is equivalent to class word contains alpha. Now I can get to something stranger though. These have the same specificity because they are an attribute selector and a class selector, and their specificity is going to be 0, 0, 1, 0. They just have one thing on a position. Now where it gets stranger is this. So I have sharp, I don't know, P1, which is going to have a specificity of 0, 1, 0, 0. And I can write this, which is not going to have the same specificity. It's going to be 0, 0, 1, 0. Okay? Does this make sense? You understand what's happening? Well, ask me some questions then. Okay. So you've seen this. Now we have a series of other selectors. So we have positional selectors. And positional selectors are going to speak in terms of ordinality of elements in a child collection, right? So if I say first child, this is going to be the first element, the element which is the first child of its parent. If I say last child of its parent. Nth child of something is going to be the element which is the third, fourth child of its parent. And last child, again, is going to be the same principle but counting from the end. Now something strange which happens here is that the index which I'm going to feed into nth child of something is going to be in display order, right? So if, for example, I have something like this, I'm going to have a series of divs, yes? This is going to be the third child. So I might select it with n child of 3. Although, if I look in the children collection, its index is going to be 2. Right? If I look on the screen, it's going to be the third visible child. They probably decided to do this because it was considered more intuitive. Now, when looking at something like nth child, I can actually use something else in the parentheses. So nth child, I can write both like this. It's going to be the third child. But also, like this. And this is going to mean all the odd children, as opposed to all the even children. I can also write something like an expression. So this is going to be all the children which have in the order have a position which is a multiple of 3. So this is going to be 3, 6, 9, etc. So I can use more complex expressions. Now, most of them are not really that useful. What is useful is odd and even, because you've probably seen the tables which have alternate styles for lines. And I can draw tables through this method without actually drawing their borders. They're more intuitive, and you can actually see the difference without wasting space. I didn't have nth of type, and of course first of type and last of type. When I said about specificity, and let me remind you that specificity is going to work like this. So I'm going to have something which is the presence of style, IDs, classes, types. Right, and I'm going to have something like this. So let's say I have no style, 0, 1, 0, 3. Right. So when I was talking about this, I said that on this position I have class selectors, then I have attribute selectors, and we've seen them, and then I have pseudo attributes and pseudo classes. Now, pseudo classes, for example, we've already seen. These are pseudo classes, right? But I also have a series of pseudo classes which relate to the state of a particular thing. For example, for an enabled and disabled input, something which I can obtain in HTML5. I can have enable, disable, so select only inputs which are enabled, or select only inputs which are disabled. Now, in HTML5, I have a series of controls, of input controls, which have rudimentary validation. So I can talk about valid and invalid, right? An input type email is actually going to try to validate my input, but it's not going to try to, I can't actually leave it to it. So I can't actually rely on it. For example, it's going to decide that the rule of validation for an email is this. This is a valid email, right? It's something which contains an "at," and this is not really enough. But I can use the classes in order to superimpose my own validation and reflect the idea of a valid input. Then I have read-only and read-write, required and optional, empty, focused, right? And these all relate to a particular state of an element. Now these actually are conceptual descendants of the fact that I've had this kind of class for links. Links traditionally have multiple states, right? Because a link might have been visited or unvisited. I might have the mouse hovering over it, or I might be clicking at this particular moment on it, right? And the styles change depending on that. And for a long time, I've already had classes for all these particular states of a link. The difference is that now I have classes for states of other things, right? Like input components. Okay, apart from this, I'm going to have, I said on the last position, I'm going to have pseudo elements. And I already gave you examples of pseudo elements. So I'm going to have first letter, which is going to select the first letter of a block of text. I'm going to have first line. Now first line is interesting because I can't actually use a tag to define first line because the browser is going to handle wrapping, right? And if I, for example, I zoom, let's just go somewhere, let's say, right, I can zoom. And I see that stuff is modified. What's the first line of the title, of the heading? I can't really tell. It depends on zoom, on device. So this allows me to select it without actually knowing what it contains and style it. Then I have selection, and selection, like I said, is going to be this, the browser selection. Now, I'm going to have something which is called the not exception. This is actually something which allows me to specify a second selector, but is not actually counted, right? It looks like a pseudo something, but it's not. It's an operator, which means that, for example, if I look into this, let's take some examples to calculate specificity and understand what we're supposed to do. So if I look at something like this, say div sharp d1 p special. How can I read this? So it's paragraphs with class special, which are descendants of a div with the ID d1, right? And its specificity can be obtained by counting stuff. I'm going to assume that the style is 0 position, so it's going to be 0, then the ID position, which is going to be 1, right? Because I have one ID, then the class position, which is going to be 1, and then the element position, which is going to be 2. So it's 0, 1, 1, 2. Now what happens if I have a pseudo class? I say something like P. Now this is going to have a specificity of 0, 0, 1, 1. Is it obvious why? Because the pseudo class counts as a class. So I'm going to have I'll count it and have a 1 on the class position. And the paragraph, the P, is going to be an element type selector. So it's going to count on the last position. Now if I say something like this, I don't know, some class for this time. Right, this is going to be, we'll have what specificity? It's a 0 because I don't know what the style is here. It's then a 0 because I have no IDs. Then it's a 2 because I have classes. Then it's a 3 because I have a div, a p, and a span. Do you understand? Does it make sense though? Okay. So I see I count pseudo classes as classes. Now let's see the not exception. Now the not exception is that not is not actually a pseudo class, but it's actually an operator, which is bizarrely represented. Which means if I write something like this, div dot alpha not sharp d1. Now if I consider not to be a pseudo class, my specificity would be 0, 0, right, 2, 1. But this is wrong. This is an exception. I said not is not a pseudo class. So what's actually going to happen is I'm going to count this as if it looks like this. And it somewhat makes sense because the specificity of something with not is the same specificity as its complement, right? So it's whatever I'm selecting here has the same specificity as whatever I'm not selecting, right? So the specificity of this is actually going to be 0, 1, 1, 1. Because I have one ID, one class, and one type thing. So I can actually read all of this, right? So this is going to be paragraphs which are the first child of their parents. This is going to be spans with class beta, which are descendants of paragraphs, which are descendants of divs with class alpha. This is going to be all divs with class alpha, which do not have the ID D1. Okay? Make sense? Okay, so let's look at precedence again. Now, for most cases, I can look at this in a simplified manner and just calculate some numbers. Like I said, the only distinction is that I don't actually have transport. I can have 13 on a position. I can have 1,000 on a position, although this is a really absurd case. So, specificity rules. Well, I'm going to correct that. So the all selector has specificity of 0. It's non-specific by its very nature. Now the type selector or pseudo element is going to have a 1 in this way. A class or attribute or pseudo class is going to be 10 and an ID is going to be 100. And if I consider in this scheme the presence of a style attribute, is going to be 1,000. So I can just add them, right? So it's a number of type selectors, etc. times 1 plus number of class attributes pseudo class times 10 plus number of IDs times 100. So it gives me a number. So I can thus compare specificity. So it's a not selector. So it's not a pseudo selector. Its content is treated like I said. Then I have important, and what the important does is it throws specificity out the window. Right? If I mark something as important, it no longer matters what specificity it has. It's going to apply. If I have more rules marked as important, they're not going to relate to one another via specificity, just via order. Right? It doesn't matter how specific they are. Okay. Now let's look at a few other things, a few other examples. Now I was saying that specificity is intuitive to a point, which means that, for example, if I'd say something like This is going to mean all p's which are descendant of this. Whilst if I say something like this is going to mean all p's which are children of this, direct descendants. And if I take somebody who's not a web programmer and I tell these two concepts to them and ask them which is more specific, they'd probably say the second one is. But when it comes to CSS specificity, it's not true, right? Because if I actually count here, I'll see that they have the same specificity, which means that although in general terms the second one would probably select less things, they're going to have precedence over one another based on order. So if I change the order, the second one is going to apply. They have the same specificity. Again, let's see another gotcha. If I say something with the attribute type, and something which says the attribute type equals text, I'd again be tempted to say that the second one is more specific, right? But again, it's not the case. They have the same specificity. Thus, they only compete on order. Understand? So if I have any kind of case like this, I actually have to calculate the specificity to understand what's happening. This is most likely going to manifest as a bug, which I have to debug. Okay, any questions until now? Before we switch to something else. Okay, so no questions. Now, so we have a selection language for the nodes of a tree. We might use this for various purposes. Maybe we want to extract text from the nodes. Maybe we want to associate handlers, event handlers to them. Maybe we want to just use them for styling. But after I've constructed the tree which has properties for each node, I can then ask myself, how do I draw this? Right. And I'm going to draw this according to a series of rules. So let's start looking over these. Now, when talking about the dimension of a particular drawable component, what I'm going to draw, by the way, is going to be a little rectangle. The things I'm going to have to take into account are somewhat intuitive. Think about the painting. Right. The painting itself is going to be the content. Now, the painting is probably not going to be right against its frame. I'm going to have some space between the painting and the frame. And this is going to be called padding. Then I'm going to have the frame itself. Frame is existent and thus defined. And then I'm going to have the position of my painting on a wall with many paintings. And I'm going to have some sort of, I'm going to have to specify how close it can be to other paintings. And am I going to agglomerate them? Just, put them right next to one right next to another. Am I going to leave a minimal space? What am I going to do in this situation? Now, this is called the box model. And we can actually see it really easily here. Well, select any element, select this div. I can actually see the little box here. Now my box is going to be manipulated through directional components, right? I mean, through directional properties, in the sense that if I think about padding, I can think about the padding top, bottom, left and right. It makes sense. If I think about the border, again, top, bottom, left, and right. The only thing that's not going to have this kind of vision associated to it is going to be the content itself. And the content itself is just going to have a height and a width, assuming that my content is something which is dimensionable. I can scale it. Okay. So, my goal thus is to draw a little box for components. Okay. How do I specify dimensions? Well, first of all, like I said, some things are sizable, are dimensionable. I can modify their dimension, and some things are not. And intuitively, something which is drawn as a paragraph is going to be innately dimensionable, while a character is probably not going to be dimensionable apart from increasing the size of a text, the whole text. I can't have a block of text and just increase the A's. Right? This can't be the default behavior. Maybe I can do it somehow, but it's unlikely that it is going to be the default. Okay, so I'm going to have height, width, then I'm going to have min height, which is only going to apply if my height is going to be lower than this, and if it's lower, I'm going to scale it to that. Min width, again, is going to apply only if the width of my object was lower than the min width. And the reverse, max height and max width. Now, when I'm talking about padding, border, margins, I'm going to have access to composite attributes. This means that if I say something like padding 10 pixels, this is going to be padding in all directions. Now I can supply values to padding either via a single value, and this is going to mean all directions, via two values, and this is going to mean top and bottom, and left and right respectively, or by four values. And the four values are going to be the four directions. So top, bottom, left, right. This applies to the other two as well. Now when it comes to border is even more complex in the sense that I have the idea of how thick the border is in all directions. But I also have a border style. For example, I can draw the border solid or dashed or dotted. Right? It can be segments of line or just dots, etc. Border color. This is going to be the color of the border. Border radius. This is going to be the fact that the corners are going to be rounded. And how this works is that if the corners are rounded, they can be considered part of a sector of a circle, right, which has a particular radius. I'm going to try to show you, but the internet, I don't know if I have internet. Because this is going to be okay, one sec, because it disconnected. This is going to be reasonably unintuitive. Let me just see here. Okay, so we can find something like this, a border radius calculator. So let's say it's going to be 1, we see nothing special, 10, 100, and so forth. Right, so it's what if this part was part of a circle which has a particular radius. So for borders, I can write stuff like this. Right, so this is going to be a border of 1 pixel. It's going to be a solid line, and it's going to be drawn with black. And this covers a lot of properties, because think about it. Everything we've seen is applicable in all directions. Right, so I can have something which specifies that the border top is solid and it has 3 pixels, right, and so forth. I have a lot of properties, and I can handle them easier like that. One sec. Now, the third thing is the margin. and the margin is going to tell me if my particular element is going to push its neighbors, right? Because if my element says its margin is 10, nothing can get within that 10 thing, that 10 distance. Now I have to ask myself, what happens if I have multiple elements specifying margins? Right? And this is how our margins treated, right? Because if I have an element which has a margin right, the first element the first little box has a margin right of 10 pixels, and the next little box has a margin left of 10 pixels. What's the distance between them going to be? And the answer in this case is that it's going to be 20 pixels, right? That it's going to be like a little buffer, like they had little force fields pushing each other away. Now that being said, margins can be specified in the negative, and then it's going to have the opposite effect. What happens if I have two children of a div which have margins top of 100 pixels and 50 pixels? What's going to be the distance top? Well, it's going to be the largest one. It's going to be 100 pixels. And so on the vertical, I'm going to just take the one which I'm going to try to satisfy all the components. If they're all in a line, the one requesting the largest margin is going to win. Okay. Now a question appears. We've talked about dimensions, we've talked about padding, margins, etc. Well, if I say something like this box occupies 50% of the screen, because I can say this, right? I can specify dimensions in percent. What occupies 50% of the screen? The content and the padding, the content and the border, and the padding and the border, right? It's a relevant question. Why? Because if I have two little boxes and they're supposed to be on the same line, and they both occupy 50% of the available width, if they have a border of 1 pixel and the width was calculated including the border, they fit. If it's calculated excluding the border, they'd occupy 100% plus 4 pixels, so they don't fit. I can't go over 100%. And the border, if you think about it, is going to be 2 pixels for the first one, 2 pixels for the second one. And the answer to this is that I can actually manipulate it via box sizes. So normally, the size of a component is the size of its content. However, I can say that so the default behavior is content box. Now this is interesting. We're going to take a little aside here. What would it mean default behavior? Or we've looked at divs at the tutorials, and we've seen that divs are display block. Where does this come from? Well, the answer is that some components have properties which start with default values. However, if I make a div blue, the other element, and it has a paragraph inside it, is it going to be blue or what? Is the paragraph going to become blue? What do you think? If I have something like this, let me explain. So I have a div and it contains a paragraph. And somehow I say that the div is supposed to be blue. Is the paragraph going to be blue or black? Blue. Yes, because some properties are inheritable, right? Which means that if I set them on a parent and the child doesn't specify any other behavior, it's going to apply to the child. Now, not all properties are inheritable. Not all properties have default values. For example, if I look at a div and I say that it says display block, what might I infer from this? That the default value of display is not block, right? Because if it was block, I wouldn't have needed to specify it. And the answer is that the default value for display is in line. And spans, for example, have the default value for display. Okay, now you might ask, how do I know? And the answer is I look in the documentation. And you should become familiar with the documentation from Mozilla, right? So if I want to say something like this, I'm going to say so dev Mozilla, and let's say I want to see how this behaves. This is a property, right? I'm going to go here, and I'm going to have little examples and everything else, but more importantly, I'm going to have this thing. So, initial value. This is the default value I was talking about. Inherited. This is whether I inherit it or not. Right. Right, but this is inheritable. So this is strange. Or if I look at we're going to look over this at the tutorial, and you'll see that this is actually inheritable. Right. If I look at display, for example, I said that it's supposed to be something which is not blocked, and it's going to be in line. One sec. Right. Right. So initial value is going to be in line. The media thing refers to the fact that CSS can actually style paper for a strange reason. Okay. What else? So I was thinking about box sizing, and by default I have content box, which means it refers to the content. Which means by default, if I had those two little boxes, two little divs, which would occupy 50%, and I'd put a border to them, they wouldn't fit on the same line. It doesn't matter for now what I'd have to do to convince them to be on the same line, because like I said before, block means that they don't admit anything on the same line with them. That being said, I can do something to put them on the same line, but they wouldn't fit. Now, you might say that I could change their width, right? I could say something it's 49%, but it becomes stranger and stranger, because I'd have to understand how the browser calculates the actual dimension. This would be device dependent, right? Because on some devices, 49% plus a border would fill the screen, and on some it wouldn't. Right? I might have some extra pixels. Instead, if 1% is more than 1 pixel, then 2 pixels, this isn't going to look like I want it. And the easier thing is to just say that I'm specifying dimensions for border boxes. And that means that 50% refers to both the content, the padding, and the border. Right? So padding box includes the padding, border box includes the padding and the border. Margins can never be included, because think about the actual purpose of margins, right? What they're supposed to do is specify component distancing. Now, components have default, like we saw, have default drawing styles, but the default behavior can be overwritten. And we've already sort of seen this, because if you think about any styles, if I can make characters in a paragraph blue, it's because I don't want them to be the default, which is probably black, right? I can modify the margins, although paragraphs have default margins. That's how they started out. Now, when I think about components, what I'm going to have is a drawing flow. I'm going to draw components according to a default way of drawing them. And I can rely on the browser to actually draw them in the default fashion, or I can specify to the browser that I want them drawn as something else. For example, assume that when a browser wants to draw, for example, a form, it's going to have to calculate where it's going to be positioned. It's going to be positioned, I don't know, 100 pixels down and 2 pixels from the left side of the screen. And if I draw it as the browser calculated, this is going to mean that it's statically positioned. Right? It's positioned as the browser imagined it should be positioned. But I can actually deviate from this, and I can deviate to a smaller or larger extent. Now, a component is drawn depending on its dimensions, its display type. Like I said, the grade categories here are block, which means similar to a paragraph, basically. It occupies all the available width, and it doesn't admit anything on the same line with it. Why do I need this and? Because if a div has a width of 50%, it still won't let anything else be on the same line, as long as it displays block and without anything else. Inline is going to mean like a character. Now, for example, spans are by default inline. Links are by default inline. What's to be noted here, this is interesting, is that inline things cannot be dimensioned, right? I can't scale them, which means I need something else. So if I use the property width or height on an anchor, it's going to have no effect. So the same property, in concert with different other properties, is going to have significance or not. Now, in order to have something which is inline and is dimensionable, I'm going to have a special display value, which is going to be inline block. And inline block, let's think about a simple example. Inline block is going to become really handy, for example, if I want emoticons. Emoticons are not going to be the same size of the text. No matter what size they are, they're not going to be the same size as the text, right? Why? Because I can enlarge the text. And that's an image, and it has a particular resolution. It's an image of some pixels or on some other pixels. The third thing is going to be its positioning. So this is going to mean if it's positioned according to how the browser imagined, or according to something else. It's in relation to other components. Because if, for example, my left neighbor has a margin, it's going to modify my position. It pushes me, like I said, like it had a little force field pushing me. I can't go inside this margin. Other external information, such as viewport size, right? Viewport size is going to be this. If I want to test something else. It's also going to be something which is can be device dependent. Okay. Now, let's talk about something else, and we'll finish this next time and talk about these all these properties. I was talking about dimensions, and I was talking about text size and so forth. So, what am I going to specify these things in? What can I use as a unit of measurement? Well, CSS is a language which was created to style different things. And this reflects in my measurement unit. And I think we've already seen EM, right? EM is a measurement unit which is going to be the default size of the text. And I can actually change the default size of the text. I do it whenever I'm zooming in the browser. However, I might want things to be sized relative to the size of the text. For example, the emoticon I was thinking about, right? If I have a little emoticon, even though it's an image, I want it to be larger or smaller in pixels, depending on how large the text is. Because my imperative here is to make it look like a character. I can size things in pixels, of course. I can size things in measurements which are generally used to measure things in the real world, like centimeters or inches and so forth. I can size things in percentages. But percentages refer to what? If I say width 50%, it's going to be width 50% of what? Of the parent, yeah. It's going to be of the available width. And the available width might be smaller than the screen. So if my parent is half and I'm half, I'm actually a quarter of the screen. What happens if the parent is half of the screen and I size myself with pixels and I'm larger than my parent? Well, it depends. I have to decide. I might have some behavior which is looks like a web page. Right? A web page doesn't necessarily fit its container, and then I'm going to have a little scroll bar. I might decide that the way the parent works is that it's drawn in front of the child like a little mask, and then whatever can't be seen can't be seen, and it's going to crop the child. And now the child is still going to have its dimension. You're just not going to be able to see it, but it's still going to be, for example, if it was 400 pixels wide, it's going to stay 400 pixels wide. You're just not going to see the pixels, and that's going to affect the properties. And I can also measure things in stranger stuff, like typographical specific measurements. Which comes in handy because the CSS can also be used to style paper, like I said, to style other things which are presentation components. I think we're going to stop here for now. However, if you have any questions,